So yeah, good morning everyone. Myself Jimmy Kumar. I'll be hosting today's session. Okay. So basically what we will do is that I'll share a dataset link and we will work on that together. Okay. Hello. Sure, sir.
Yes, sir.
Yeah. So first of all, I'll share the dataset link to you guys. Okay. So you can open a collab, a blank collab. Okay. And yeah, I'm just sharing a dataset link. Once you guys load the dataset, then yeah, just message or yeah inform. After that, we'll start. So yeah, I have shared a dataset link in the chat box. Okay, you guys can open that. And yeah, once again. My screen is visible now.
Yes, sir, it's visible.
Yeah. Okay. So that this dataset belongs to is a car dataset. So let's say you are working as a data scientist in a big automobile company. Okay. So your company has to enter to the US market. Okay. So before entering to the US market, obviously you will try to understand what are the constraints, what are the factors which is affecting the car price and all, so that you can propose a competitive model, I would say. Okay. So yeah, any message maybe. Okay. So yes, so yeah, I pre.
Yeah, sir, I had a question regarding the dataset.
Okay.
Sir, there is a column titled symboling SYMBOLING.
Yeah.
Uh, so, what does that indicate?
Yeah. So I'll go. So here also you can see that it's a sign insurance uh, risk rating. Okay. A value of +3 indicates that the auto is risky. -3 that is probably pretty safe. Okay.
Oh,
So
okay,
okay.
got it. Thank you,
Yeah.
sir.
Okay. Thanks. Yeah. Before going to that, yeah, let's understand the context of this dataset. Okay. So yeah, that is what I want to show you people here. So you have to see that any company if enters into the new market, let's say some company comes to the India, so obviously he will first do all the analysis so that they can propose some competitive market. I mean, what is the range of the price of different cars, like which car, which type of car people like. I mean, the front door or front engine, back engine, something, all these things. Okay, so just think from the data science perspective, data scientist perspective. Okay, just see you have some data set. I mean, you have some information from the US market of US market. So you just try to think like how you will propose. I mean, what suggestions you will give to your company. Okay, so that is your goal here. Okay, so first thing would be, I mean, here first thing would be to load the data set. Okay, and yeah, you can refer this table or yeah, and first you just load the dataset and see what are the different features. Okay, after that we'll move. I mean, so one question. So everyone loaded the dataset? in their collab, or is there anyone who is facing issue?
Sir, I've loaded the data set, but have you also shared this collab, or how do we know the individual description of the fields? Where
Okay,
can we
okay.
input it from?
Oh, features. Okay, yeah. So we haven't shared this collab here as of now. I mean, yeah,
Okay,
it will be shared after this session.
out of the session. Okay, okay. No, no. Can I just do a describe on the data? It will show me something, some documentation. No, no.
Okay, okay. So, okay, I'll just follow
Yeah,
Sir,
reference
that
here.
after
will
the
help.
session, we'll get.
Yeah. Yes,
Sir,
we will
after the
get it.
session, we'll get this collab link in the portal itself.
Yeah, yeah. Yeah, we will upload this PDF. Okay, PDF version of this collab.
Okay, okay, got it. Thank you, sir.
Okay, thanks.
Thank you, sir.
Yeah. So yeah, I've shared the dataset description in the link in the chat box. Okay. So yeah, that's all about the dataset. So yeah, if whoever is done with the whoever has already loaded the dataset, they can raise their hand so that I can get the count. I mean, how many people? Two people. Okay, three, four. Yeah, description is not there. Okay, there is a size limit to meet chats. Okay, okay. Yeah, so yeah, you can.
Actually, you sent the whole thing, but it didn't like
Okay, okay, okay,
the whole
okay.
thing
Yeah,
didn't come yet.
yeah.
It cut out from engine location. From engine location onwards, I think you need to send again.
Let's try. Okay, engine location was not there, and now it's compression ratio. Okay. Okay, where is the compression? Yeah, here is the compression ratio. So I think there are few things which a normal people won't understand, and otherwise everything can be. Yeah, a layman can understand. Okay. I mean, no length of car, width of car, height of car. So yeah, there are few columns. I mean, which a normal person can't use, like emballing, then aspiration, and you can say this one also. I mean, wheelbase people can understand. Curve weight. These are the technical terms. Okay. And yeah, compression ratio or yeah, other thing people can understand. Okay. So here see, this data set is completely lot of the feature engine can be done on this data set. Okay. So I think yeah, I assume there are two category of people here. So there are few people who has experience on working with data set. So for them, I would say yeah, you can do some basic inspection of data set and you can create some good features like yeah, you can create some good features from here like different car brand names. You can clean that and also apart from that you can do some you can modify some I would say some columns. Okay, and based on that you can work. Okay, and I'll try to focus on this session to the other peoples like majority of people who is completely who is learning this machine learning in this course only first time. Okay, who is learning for the first time. So I am just trying to give you a introduction on how these things work. Okay, how you get a real world data and yeah, and how you should think. So that's the goal of this session. Okay, so first thing is that have you guys loaded the data set? Okay, so I assume that you have loaded the data set. Okay, so so first part would be that you have to inspect the data, like what are the how many how many number of data points are there, how many features are there, how many categorical features are there, how many numerical features are there, how many NA values are there. Okay, so let's try these 7 questions. Let's try to answer these 7 questions. Okay, uh, once you are done with all these 7 questions. Okay, oh okay, so once you are done with all first 3 questions, just put the yes in the chat box. Yeah, that's what I will.
So just a quick question. So I have loaded it as pandas data frame. That's okay, right? That's what we need to do, right?
Yeah, sorry.
No, okay, that's fine. No, I've loaded it as pandas data frame. I was just wondering whether that's what we need to do.
Yeah,
That's
yeah.
okay.
So you have loaded the pandas data frame. After that, just load this data set. I mean, have you downloaded? There can be two methods. I mean, basically three method can be done. By three method, you can load the data set. So is there anyone who doesn't, or yeah, who don't know how to load the data set in the collab? I mean, anyone? Okay, so whoever has raised their hand. So there are few raised hands. So that these raised hands for that last question or what? Yes, Yogendra has completed basic data inspection. Great. So maxing, I mean, okay, loaded CSV. Is there anyone who hasn't loaded CSV? So Mac, have you loaded CSV or
So
you
can
have
you
raised
please
hand?
send
Or,
again? I joined.
okay. So
I have loaded CSV file.
okay, that is what we need. I mean, okay, Mac, yeah. You can use this link to load, download the dataset and load it in a blank collab. Okay, so that is what it, as of now you have to do. Okay, and after that we will move forward. So whoever is loaded the dataset, they can try to answer these three questions, first three questions. Okay. So once you will be done with these first three questions, okay. After that, we will move forward. So yeah, I'm pasting the first three questions here, the chat box. I think we should have some other ways to communicate. Okay, I'll just share a doc. Okay. Here, I mean, whoever just write your name and you are done with the dataset, then you can simply. Yeah. So here you can answer. I mean, you can use this doc. Yeah, here you can just write your name and yeah, for each questions you can write your answers. Okay. So this is the doc you can
Sir, can you
use.
show the second part of the code? Because I'm not able to load it from Google Drive. I've just wrote the.
Okay. Yeah. Okay. So you just download the dataset and you can directly upload it. Okay. So this is what you can do. And other than that, you can just mount the drive. And after the, if you have saved it in your drive, if you have copied the dataset into your drive, then you can mount it. And yeah, let's say from here, you can copy the link of your dataset. Okay. That is a different way. And some second approach can be that yeah, you can directly run this code. Okay. Once you will run this code now, you will get the options like this, choose files. Once you click on that, then just yeah, select this dataset. Let's say this is the data, and once you will click on the open, it will load it. Since I have already loaded, so yeah, I won't take. Okay. So since I forcefully stopped this cell, no, so that's why this is the error. Otherwise, yeah, it won't throw any error.
When sir, to load from Google Drive, we need to write these two cells that you are showing right now.
No, yeah, this one will only work. I mean, this was the you have to mount your drive on that case when you are trying to copy your dataset from your drive. Okay. Otherwise, this one is okay. I mean, you have to run this code from google.collab import files and yeah, from files.upload. If you are using this one, no, I mean, if you are using this, then uh, here you will see these options. Okay. Here you can click on the drive and yeah, this is the my drive, and from here I think we can see here there would be okay, yeah, here is the data set. So okay, here I can see, I mean, this is the car price in the US market. So from here I can click on this copy path, and yeah, this can be another way. I mean, you can directly copy this link. Okay, from here also you can do that. If it is saved in your drive now, then you can use this. Otherwise, if it is saved in your local hardware, yeah, hardware, no, in that case, if it is saved in your local hard disk, then yeah, you can do this like this. Okay, I mean, if it is in your laptop, yeah, then you can use this code. Okay, it will work. And this is the alternate way. So
what are the three things?
you have to mount. Yeah, sorry.
No. What are the three things for data inspection? I didn't.
Yeah. Okay. So yeah, these are the first three questions for data inspection. Okay. Number of data points, number of features, number of categorical features. Yeah, these three things I have asked you to answer. Okay. I'll copy this also in this. This will work. I mean, yeah. I'll copy all the question set. And after that, I mean, yeah, you can increase the, you can add new pages in this sheet, and yeah, just write your name at the top, and after below that you can answer all the questions. Okay, so that you can do here. Okay, for now let's skip these. Yeah, these two sets only. Okay. So yeah, since this is the first first SWI with this first SWI of this type of thing, I mean, you are loading the real world data, so that's why I'm taking time. I'm giving you the enough time so that everyone just move forward with me. Okay. So yeah. So the first question is number of data points. So how many data points are there? Can you guys answer in this?
There are 205.
Okay. So yeah, I would like if you guys just write your name here. For example, let's say someone can tell your name. I mean, okay. Tell your name. Okay. First is just keep it for me, and yeah, from the second page, some of you can write your name here. Let's say anyone. Okay, and here you can answer. First question, answer 205 cross this one, or whatever you are saying. Okay, something like that. Second question, like that, you can just take some place in this document so that I can easily see.
So we're not able to edit here.
Oh, you are okay. Sorry. Okay, yeah, thanks. Yeah, I have no idea. Yeah, just try to do that. Hi, you guys. Do you want to ask anything? Okay, sorry, I didn't see. Yeah, you can just now I give the access.
Yeah, I have one question.
Yeah, please ask.
Why this head and like that is not working for this? It is a data frame. Okay, I type as I wanted to know type. It is showing data frame, but I want
Yeah,
to
it
know
is. Okay.
df dot shape. Like I have given
Yeah, it
name the
is
df.
working. It is working now. I mean, see here. So dataset.zip will work.
Okay, okay, I got now got it.
Yeah. Since it's a data frame, yeah, these things will work.
So 205, 26 it is showing.
Okay, okay, yeah, that's correct.
Yeah.
Yeah, you can write your name here also. In this way, I can also see like how many people, how many of you are active here. Okay. So Mahak has written her answer on this document. Okay. Others who all are active, just write your name. Okay. Preet has also, yeah. So Vikas has also started writing their name. Take some space, yeah, and after that you can start. Okay, as I can see that, yeah, most of you, yeah, Max, Vikas, and yeah. Don't worry, I mean, yeah, everyone just try to answer, just try to write some codes, okay, by your end. Let's see, I mean, how you go.
So please give edit access.
Now it is there, no? I mean,
No,
I
I
think
am
it
not
is.
able to do it. Sir.
Yogendra, I think you need to use your IITM ID, maybe.
I am using the same ID, sir. ID.
Anyone with this link, I have, okay, just see here.
same issue is here, sir.
Is it? I mean, I'm again copying the link here.
I'm not getting any access to.
I'll just see here. Okay. This here I have shared the link. I mean, see, Week-4 SWI is there, and anyone with this link can edit it.
Yes, it's working now. Sir.
It's working. Okay. Now. Yeah. Yeah. Since enough questions are there, so whoever is done with the first six, 7 questions, they can move to the next questions also. Okay. It's not an issue.
So, sir, number of data point represent number of column.
Number of data point.
The first question is number of data point, means number of rows, sorry.
Okay. Yeah. Number of rows it is. Yeah.
And number of feature is number of column, excluding data.
Yeah. Exactly.
For some reason, I'm not able to get access at all. I don't know why.
So someone is there. I mean, still you are not able to get the access.
It's saying request, you can only view this document to make changes, ask the owner for edit access. It's saying, I don't know.
Maybe reload the page. Then.
Yeah. That I think.
I tried that also.
So what it is saying? I mean.
Yeah, now it's working. Thank you.
Okay. Mahak, Vikas, Yogendra, Hazel, Sukhdeep, Sachin, yeah, Naren. Yeah, so yeah, many people are active now. So that's a good. See, speed is not an issue, okay? Because anyway, I will share this collab, so you can work on it later also. But at least you should know the pattern. I mean, how I would like to, yeah, how you will progress in this collab. Okay, I mean, so first what you did here, yeah, I mean, you just see, you just check the, I mean, how many data points are there, how many features are there. Okay, and after that, yeah, like how many categorical features, how many numerical features are there. So to check the number of data points, yeah, you can directly click a dot, say dot save, and yeah, here you can press 0. Okay, so that it will give you the first value. So what it says, it is saying that 205. So according to it, you have 205 number of samples. Okay, so after that, to check how many features are there, yes, you can click one. I mean, you can use one here. It will give you the how many number of columns are there. But here if you see here, we have mentioned that, yeah, this one is a price is a dependent variable. So I have already said that this is your target variable. So this is not a feature. Do you got it? I mean, so based on that, you can say here you have 25 features. Okay. Hello. Usually you won't see this. I mean, usually we don't mention at the start only that, yeah, this one is a dependent variable. So in that case, you can say, yeah, you have 26 features. But yeah, here, since we have already mentioned that, yeah, this one is your dependent variable. So yeah, you can say, okay. So after that, just do some basic inspection of your data set. Okay, so that how many, yeah. So I mean, how to guess how to get the last 5 rows of your samples. Hello.
-5.
No.
So you have option of tell, not -5, yeah, or that you can use. Okay, so if you use this dataset.tell, it will give you the last 5. Yeah. Okay. One thing. Okay, so here if you see that, yeah, if you use 5 dataset.tell, then it will give you the last 5 rows. Okay, and if you use dataset.sample, okay, if you use dataset.sample, no, it will give you the random 5 samples. Okay, since I have mentioned 5 here, so it will give you the random 5 samples. Okay, just see here the index value. Okay, so what would I mean, so what would be the good way? I would say the good way will be to use the samples only, so that you get the random 5 samples or random 10 samples, something like that. Okay. Hello.
Why it is good?
Yeah, because these are the randoms. I mean, they're in few data sets. I would say that, yeah, first 5 belongs to the same category only. Okay. I mean, let's
Okay,
say,
okay, okay, okay.
yeah, for
Bunch,
that case.
yeah.
Yeah. So that's why I said okay. Otherwise, it's okay. I mean, we are not taking any decision based on this. We are just seeing like what is the features. I mean, how many types of data sets are there? What are the what is there inside in a different columns? Okay, to get some idea. Okay, for example, here if you see that, yeah, car ID is there, so sampling is there. As we know that sampling is denoting the safety of your car. Okay, it's assigned insurance risk rating. A value of +3 indicates that the auto is risky, and -3 indicates it is pretty safe. Okay. So just to get the idea of the data set. Okay, fuel type, you know that, yeah, gas and diesels are there, and yeah, door numbers, I mean, how many number of doors are there in the car. So what is the car body type, drive wheel, engine location. Okay, these things are there. So your final dependent variable is here is price. So you have to predict the price. I mean, that is what you have to do. But two things comes here. Okay, first thing is that, just once you load the data, no, you have to check two things. Okay, so first thing is that you have to check, I mean, is there any null values, and after that you have to also check that whether there are any duplicate data or not. Okay, to check that, I mean, see here, we can use two methods. Okay, So one method, is that yeah, we can directly write a code dataset.info. So it will give you the type of data in each column. Okay. So if you see that we know that we have 205 number of samples. So everything here, all columns are saying yeah 205 non-null values are there. So it means that yeah, from here also we can get the idea we don't have any null values in any columns. Okay. Otherwise also you can use the dataset is null. Okay. I mean dataset dot is null. Okay. So it's a boolean type. Okay. But if you use the dot sum, then it will give you the exact number of null values in each column. Okay. So we are seeing that yeah, we don't have any null values. So no need to worry about the null values. So if you would have null values, then there you can use different techniques to impute the null values. Okay. So I mean, do you know? I mean, what are the different ways to replace the null
Excuse me,
values?
sir.
Yeah, please see. Yeah, Preet. So they
Sir, what is the difference between dataset.isnull and dataset.isnull.sum?
dataset.isnull and dataset.isnull. So if you use dataset.isnull, no, see, it will return the boolean values, true, false, something like that. Okay. If you see, okay, it will return something like this. So if we apply dot sum up to after here, no, so it will count. I mean, how many trues are there in each column? Okay. So it will return that. Anywhere, I mean, if you see that, no, if you use, if you are getting some
So,
boolean values,
so a false, sir, a false in is null. It indicates that it isn't null. That means the value is there,
yeah,
right?
yeah, there is some values. So it is asking whether it is null or not. So that is the
Okay,
question
okay.
we are asking here. So yeah, it is saying the false. It means yeah, are some there, at this state there is some values. Okay, so you can use the dot soon here. Okay. See, one thing I would say, yeah, these are the basic operations you have to do in each data set. I mean, in each OPs you have to do these things. Okay. So at least I would say, yeah, just be comfortable with all these steps, all these basic steps, because yeah, 10, 20 marks will be there. Always they will be there on this, on the OPs, each OPs, OP1, OP2, everywhere. Okay. And yeah, these are just 8G marks. Okay. So the next step comes to dataset dot is describe. Okay. So if you click on this, okay, so it will give you the description of your data set. Okay, basic description, like what is the mean value, what is the standard deviation, what is the maximum value, okay, what is the average value. All these things will be given just on one click. Okay, for each column here. So yeah, at some moment you can see that yeah, the not every column or every number is giving you some good insights, but there are few things which can give you the good insights. So, let's say for car ID, mean, average, or any values, it doesn't give you any insights. Okay, but if you see here, average symboling, it is giving you some idea. I mean, most of the cars are has symboling more than 0. So I mean, most of the car. Can I say that yeah, most of the car doesn't have good safety or something like that? Can I comment? Because I'm commenting that because the document says that yeah, +3 means +3 means that the auto is risky. Okay, and -3 that it is probably pretty safe. Okay, so based on that I'm commenting it. Yeah, please say.
So one question, what is the difference between is null and is now?
Is null and is NA.
Yes sir.
Is NA. Okay,
Yes sir.
it's not an issue. I mean, both will give you the same answer only. Okay, is null or is NA both gives the same answer. But yeah, in NumPy you have is nan. I mean, numpy dot nan is nan. Okay, but yeah, in NumPy you use the is nan. Have you seen that? Okay, but for here you can is na, is NA, and is null, both works. Yeah, both does the same work. Okay, so yeah.
So this null is to identify zero values or what?
Yeah, if whether it's any zero values are there, and not a zero, I would say it identifies that whether here, let's say here it is written as NA. Okay, sometime you see that there are no value is mentioned here. Okay, it doesn't represent zero, I would say. It represents the, I mean, there are no values here. Okay, if in your data set zero denotes that there is no value, then you first to do any operations you have to replace those zero with np.nan.
Okay. And if some special characters are there in Excel sheet,
Yeah.
then how
Yeah,
we will?
then in that case also you just replace it with np.nan. Okay,
Okay.
then after that, yeah, you just move forward, because there are no other ways to handle to understand, I mean, there are no other ways to uh, handle those special characters and all. So that would be the first step here. If you see that in your data set for null values or any missing values, it is mentioned by some let's say this double quote. Okay, sometimes you also see like this is also an, I mean, we know that, yeah, this is not any value. So yeah, we will replace all these things with np.nan. Okay, so yeah, the string dot replace by using that code, yeah, you can replace these things, okay, with np.nan, and after that you can move forward. So yeah, that is the thing. So see here, so we symboling can give you some insights, and here is the average price. So you can see here that average price of cars are $13,276. Okay, this is the average price of car. And what is the maximum price of car in the market? It is $5,400. Okay, and the minimum price of car is that 205. Yeah, I think 7988. Yeah. So this is the average price of, I mean, yeah, minimum price of your car. Okay, no, sorry, just the row below this one. Yeah, 5,118 is the average yeah, minimum price of any car, any auto. Okay, so yeah, so from these things you can get some idea, okay, about your data set. So this is the second step, and it depends on you, I mean, how many insights you can take from these things. Okay, it completely depends on the data scientist, and no one can teach you that. Okay, it depends on your creativity, I mean, what you interpret. So these are the codes. It will give you the data, and ultimately it's you who will get some insights from these things. Okay.
Sir, could you please explain dataset.sample command? I'm not
Dataset.sample. Yeah,
Yes.
sorry if your voice is new. So dataset.sample will give you the random five sample. I mean, it will give you random samples. Okay. So since I have mentioned five, so it will give you me random five samples from these 205. Yeah, 205 samples. Okay. Is that what you want to know or anything else?
Contains are same, like what is the what the dataset contains. The same things appear by running this command.
Here.
Yeah, yeah, data.
Yeah. From the data set, I am selecting five random samples. Okay. If we are using dot head now, it will give me it will give me first five samples. Okay.
Okay, so
You see
it's
the index.
indem,
Yeah,
indem.
0, 1, 2, 3, 4. Yeah. In
Yes, yes.
yeah, that is what it will give. Okay. And dataset.info will give you the yeah. Okay. Dataset info, dataset data describe. Yeah, these things are the basic steps. I mean, you have to do on each dataset. So one thing you saw here, I mean, you had 25 columns. I mean, yeah, 26 columns you had. But here, how many columns you are seeing here? I mean, 3, 5, 7, 9, 10, 11, 12. And yeah, around 15, 16 columns you have. So do you understand here? I mean,
It gives the statistics about only numeric values.
yeah, exactly. It is giving you output as a only numerical value, because it doesn't make sense to I mean, you are making a minimum or maximum or mean of any categorical column. So to handle that, here is a option. I mean, include. So there is a parameter name include. So basically, currently it is by default it is include numeric. Okay. If I take it as include all, no, I mean, yeah, I would have to. Okay, yeah. If you change it to all, no, So then it will give you all, I mean, yeah, it will give you the all columns. Okay. So if you see here, I mean, it doesn't make sense to, I mean, for car name, let's say for car name, if you see here, I mean, for categorical columns, frequency or unique value, these things make sense, but standard deviation, minimum value or maximum value, it doesn't make sense for the
But
categorical
sir,
column.
like they could give numerical value to like Toyota and other cars, and then calculate mean and standard deviation, like how many times they appear in that row, you know, that
So,
column.
sorry, just say what you said.
I was saying that like there are so many car names, so they could give a number to each and every car. Like they can count the number of cars for each brand, and then they can calculate mean, standard deviation, many.
Okay, so based on the car frequency, that is what you are saying, no? Yeah. So,
Yes, sir.
but
Car.
yeah. That is that can be done, but yeah, this code doesn't do that. Okay, that is what I would say here. So, but yeah, here it is giving you the, I mean, the maximum frequency of the top cars. I mean the top numbers. Okay, for this, it doesn't, your code doesn't understand that whether it's a car or anything. Okay, it is something, understanding that this is a categorical feature and it is some string, or this code, it is like that only. Okay, and it is checking that it is checking like how many times this Toyota Corona is uh, repeating in the your data set. So it is repeating for the 6 times. I mean, there are it is representing that top values and its a frequency. Okay, so for first one, it is describing that, and whatever you said, yeah, that can be done, but yeah, your code, this code doesn't do that. Okay,
So
yeah, I got your point, but yeah, that
Sir,
does
about
not work of this code. Yeah,
sir, one thing. So can we take this description separately on the numerical features and categorical features?
yeah. So that is what I'm saying. See, here if you see, the by default it is numeric only. Okay,
Okay.
by default it is numerical. So if I didn't mention here, no, so so it was numeric only. You see here, it is numeric. If you want to take the only either you can take it as a numeric, or otherwise you can take you can include all. Okay, something
Okay.
like that you can say. Okay,
Okay.
yeah.
So, but the columns are completely different for categorical and numerical values. So,
Yeah.
description.
Yeah. There were few new new rows, I would say. Yeah, like the count. Yeah, frequency was there for the categorical column. Yeah, and top repeated. I mean top values. So which is so it means that it was, so this describe function was working like it was also checking. I mean, in each categorical column, what is the string which is repeating most of the time. Okay,
Okay.
repetition of, so it was giving that also. Okay,
Okay.
so see, yeah, so after that you have to see what we had to do here was that so third question was we had to check the how many number of categorical features are there, or how many sorry, so number of features. And yeah, okay, we have list of all features. Okay, number of any values we selected, number of categorical numerical features. Okay, so how you will you count that how many number of numerical features and categorical features are there? One thing you can do is that you can directly count here. Okay, I mean, you can directly count how many number of I would say, yeah, how many number of features are there. Okay, from here also you can see that, yeah, we have how many category features are there, 1 2 3 4 5 6. I mean, you can manually do it because here we have less number of columns. Okay, but what if we have 100 number of columns? So would you do that? Or second thing, you can from here also you can understand, I mean, how many number of I would say,
So
yeah,
at the bottom it is coming, bottom.
okay, yeah.
Yeah.
Yeah, okay. So here you can see that, yeah, you have integer as 8 and 8 as float. So yeah, integer and float both are numericals only. So 16 is a numerical column, and yeah, 10 is a categorical column. Okay. So from here, data types also you can understand that. Okay. Second thing, what you can do here is that dataset dot describe. So it is giving you this data. It is giving you this data frame. So if you check the columns of the, I mean, if you check the column name of these, so you know, no, I mean, these are the numeric columns only. So So if you somehow if you get the count this one also, I mean the number of columns of this one, then that will also give you the correct answer. I mean how many number of numerical features are there. Okay. Do
So
you
there's
guys?
also one method,
Yeah,
like
please.
it's d types dot value counts.
Yeah. That is what I mean. Yeah, we discussed here. D types of values, no? Yeah. Yeah,
But it only
8860.
gets that. So
Yeah. That's true. It can give you the number of categorical columns and number of yeah, numerical columns. That's true. And yeah, so now the next question is to get the list of numerical features and categorical features. So how would you do that? Can anyone suggest the method? Anyone?
So it should be select data types equal to numeric and object like that.
So have
So
you
I
done that?
pasted something. Yeah, I pasted something also on the chat.
Okay.
Yes,
So yeah, it would be nice like if you guys share your yeah, like how you proceeded from here, because otherwise, because anyway my collab will be there with you guys. So yeah, if someone has done some any alternate method or any method, so that would be, yeah, that would be good to see. Okay. So anyone would like to volunteer? I mean, anyone who would like to show his or her code to all of us? I mean, there can be many methods. So first method can be that, yeah, you can put a conditions like if data type is float, then yeah, add it into the list named. You can run a loop, and in that loop you can say you can put two if conditions like if your data type is float or integer, then add it into the numerical column, and if otherwise you can add it into the categorical column, or I mean categorical list, and at the end you can print that list. So that can be a one way, and we can also take benefit of these operations. Okay, so since we know that data set or describe is giving all the columns inside this data frame is numerical type only. So if we write the dot column of after this one, no, okay, so this one will also give you the list of all the columns which is available here, so which is ultimately numerical columns only. Okay, and after that, okay, so that is what we have done here. Okay, so first we selected all the features here. I mean, we simply typed dataset dot columns. Okay, this code will do nothing but just give you the list of all the column names. Okay, so yeah, these are the features here. Okay, and one thing we missed here, I mean, we should always check the if there is any duplicate data in your data set. So why it is necessary to check this? Can anyone share their thoughts?
Skewness. It will lead to skewness.
It will
It
lead
will
to,
change also statistics also.
okay, yeah, these 2 points completely true. Any other points? Yeah, so yeah,
So it may lead to underfitting or overfitting, sir. Based on the type of what is the size we choose, it may lead if it duplicates.
one thing I would say, see, if we have the same, I mean, let's say we have the same data set, okay, I mean same samples again and again, so it won't add any extra information to your
Voice is
system.
not clear, sir.
Hello, so is it clear now? Hello.
Low volume only. Low volume. Can you?
Okay, one sec. So noise cancellation is off. Yeah, is it better now? Hello.
Yeah, a little bit better, but Can you speak again, please?
Hello. Hello.
It's clear, sir.
Yeah.
Yeah. Okay. So okay. Okay. So yeah, here we saw that from these codes we can get yeah. Yeah. So if you see that dot duplicate will remove all the redundant samples. I mean the same info. So duplicate means that let's say if this is the sample is there, no, same thing is repeated 4 5 times or more than one. Okay. So it will count as duplicate. Okay. So if you remove that, then obviously you are reducing your time to complete the process or to run the code. Okay. And it will I would say that it will play a crucial role when you go into the company where you have to pay something for each run of your code. Okay. So that's why it becomes necessary to remove the duplicate samples, because it is not adding any value to your code or your model. Okay. So that's why it is necessary to remove the duplicate columns. Okay. So always check. I mean, so here if you have since we have written a dataset dot duplicated, so if you see that dataset duplicate will always print the it will return the boolean values. So yeah, so for if we have written dataset dot this, no, so this will return all the samples which has duplicate values. Okay. And if we select the length of duplicate values, then yeah, it is giving us 0. So it says that our data set has no duplicate value. So yeah, what is the code to remove duplicate values? Yeah, you can drop that directly. df dot drop duplicated. Okay. df dot drop duplicate. You have that. Okay. To drop all the duplicate values. Or for to drop the NA value also you have df dot drop NA. Okay. So by using that
Drop underscore NA, right? Drop underscore NA.
Yeah.
Okay.
I mean that only. Okay.
No, I'm
This.
just confirming more than.
Yeah.
Okay. Thanks.
Drop duplicate for that also. Okay. So yeah, that's how you can remove that any values and duplicate values. Okay. And here if you see that by using this one you are getting all the columns which has yeah, you from here you are getting all the columns. Okay. And after that someone has shared the code, that code will also work. Yeah, length of
Sir,
yeah.
so this feature you have to exclude the label, right? So, but in this code you have included the label also, the price per feature.
Okay. In this one, yeah. We can remove that. We can remove that features dot remove that. Yeah, you can remove this one. Okay.
Okay.
Either by slicing or yeah, that using that. So yeah, here if you see, I mean yeah, from there. So at least you know, or you know that your data set. Okay. And to get the categorical features, you can write a code where you can see where for numerical features, as I said, no. Okay, I think I would have done that. Yeah, here I have done. So numerical features is nothing but data set did describe dot columns. It will give you the numerical features, because as I said, by default it is set here. By default here it is written as a include only numerical. Okay. Okay. By default it is there. Okay. So this is there. Okay. So here it will return you, and this code will return the only the numerical columns. Okay. And after that you can run a code to check, I mean whether it's if it is not there in this one, so it means that those columns are categorical columns. I mean if any column, I mean among so this it is the total columns list, and this one is the numerical columns list. So total minus numerical will give you the categorical columns list. So did you got this point, or any other code also you can use? Okay. Or okay. So after that, the ADA comes into the picture. Okay. So what would you do in the ADA is that you will try to understand each and every columns. Okay. And just try to get how many insights you can get from the from your tables. Okay. So for now here we have printed all the columns. Okay, histogram of all the columns. From this histogram you can also get some idea, or otherwise so from here at least you see, I mean there are many if you see that car IDs, I mean there are many unique car IDs. Okay, so as we know that the car ID for all the column, I mean all the car are unique, so that's why we are seeing here. I mean, so that's why we are getting this type of shape of this car ID histogram. Does it make sense?
Yes, sir.
Yeah. So and now let's move to the second column. I mean symbolic. So I mean there can be you guys can also suggest some other insights. Okay. So these are the, whatever I am saying that is coming instantly into my mind. So that is what I am saying by seeing the pictures. But any insights that is coming in your mind, you can share that also. Okay.
Sir, are we also looking at this possible distributions from these pictures?
Yeah, everything. I mean, whatever you want to extract information, whatever type of information you want to extract from this table, that is good. Okay. So I think, are you? I mean, due to some puja chants and all, so due to some loudspeaker, I think the audio is getting disturbed. So is it audible? I mean, is it hearable?
As long as you're
Yes.
talking, it's okay. Yeah. As long as you're
Okay.
talking, it's okay.
Yeah. So yeah. So in the symbolic, if you see here, I mean from this table, let's see. I mean there are so we see from this table, from this graph, we can directly say that there are five categories or six categories. Okay, and as we know that yeah, the three represent the two risky cars, and minus two represents, I mean minus three represents the most safest car. But we can see from this graph is that there are very I mean there are no cars which is completely safe, something like that. Is it that can we say that?
Yeah, -3 is absent, right?
Yeah,
That's why.
minus 3 is completely absent. Okay, or maybe 1 2 will be there, so that's why it is not visible in this table. Okay, so that is there, and most of the cars are I mean most of the cars follows the, it is a kind of random normal distribution. Can we say that, or don't know? I mean, what would you say this? Yeah.
Can we also plot pie chart also, so that we can see the percentage of the
Yes,
car
yes,
like
yes,
that?
yes, yes. Yeah, something like that we can also do. Okay, but since a lot of things are there to cover, so yeah, I mean yeah, these things ideally I should share this I mean ideally I should share this data set, and would have share I should share this data set 2 3 days back only, and yeah, I should ask you to do the ADA part, and in this part in this session we should focus on the ML part only. Okay, so basically you should get the information here from these graphs also, that we can see that yeah, most of the car which is available in the market are very, I mean it is, I mean neutral type, and there are enough, I mean significant number of cars which is too risky. Okay, according to the insurance engine rating. Okay, these three represent that. Okay, there are very small fraction of cars which is on the safer side. I mean, if you see here, there's 20 around minus one, and yeah, around I think yeah 4 5 something like that. And if you plot, you can plot this since to just save the space. I have plotted all these tables in this one only. I mean, just by 4 we can change that to, obviously by we can by changing the shapes and all. We can increase the size of graphs also. Okay, so that's not an concern, and we can see that most of the data sets are and most of the tables are skewed. I mean, actually none of the column is normally distributed. Okay, and also we can see that price is highly skewed, I mean towards the 10 towards 10,000, or what I would say that towards the lower number of price. There are very few cars which has very high price, and which it completely makes sense, because obviously there will be very few customers who will pay a lot, I mean who will keep high price cars, I would say. Okay, and most of the cars also we can see that the most of the cars horsepower HP is around 50 to 100. something like that, or 50 to 150. And compression ratio, is there any person who is from mechanical engineering background?
Yes.
Yeah. So yeah, at least yeah, you can give some insights. I mean, why this type of shape is there for compression ratio, and what does it means?
Diesel engines have a lot big compression ratio, and petrol engines have a smaller compression ratio. So
So
maybe
yeah,
that's a differentiate between diesel
yeah.
and petrol.
So it simply means that yeah, there are very few petrol cars and there are high number of diesel cars. Sorry, there are high number of petrol cars and there are very few diesel cars. Is it what
Right.
yeah, yeah. So something like this. What why I took this example is that there are few things which a person from who has a background of that domain, no, they can understand. Normal person can't say anything. Can't they can only see that yeah, there are many cars which has compression between 0 to 10. There are very few cars which has compression speed between 20 to something like that. But whoever has the background of mechanical engineering, or yeah, who knows who has a good information about the car, they can understand that yeah, since diesel engine has a high compression ratio, so all these cars which have whose compression ratio is above 20, they belong to the diesel car, and yeah, these are the cars which represent which is these samples denotes petrol cars. Okay, so that is what here we can say. Okay. So yeah, something like that. And also see here you see, if you see, this is the city MPG and this is a highway MPG. So city MPG is nothing but yeah, it is representing the mileage of your car in the city, and highway MPG is nothing but it is representing the mileage of your car on highway. So from this graph, can you make some comment? I mean, which one should be greater?
So there is
That,
high correlation. Looks not in the range
yeah,
of 20 to 30.
yeah, yeah. So because basically both is mileage only. Okay, so if some car is giving good mileage on highway, then it will also give good mileage on city also. But yeah, it will be. I mean, there would be very high correlation, but it doesn't mean that yeah, if some car is giving I would say 100 mileage of 100 on normal 100 liter on highway, then it will give little lesser than that on city. It is something like that. Do you guys agree on me? Agree with me on this point? Hello.
Yes, sir. Yes, sir.
Yeah. So that's why we are saying that a very high correlation between city MPG and highway MPG. Okay. And obviously for each columns, I mean the city MPG will be little lesser than that columns, or sorry, that samples highway MPG. Just check on the data set. Okay, that is my assumption, and yeah, I also don't know, but yeah, I assuming that will be there. Okay, so here also we can see. See, if you see that, yeah. Hello.
Sorry,
If
go
you
on,
see-
go on.
yeah.
I'll ask my question after this.
Okay, okay. Yeah, so here we can see that city mileage, average city mileage is 25.21 and average highway mileage is 30.75, which completely makes sense because obviously a car on highway will give you the little higher mileage. Okay. Same thing, I mean, see all the values are highway MPG and city MPG. Always highway MPGs are little higher than the city MPG. So that is what I was saying. 49, yeah, this is for 54. And minimum also, yeah, 16 and this is 13. Okay, so I think yeah, our points are valid here. So any other information, I mean, by seeing just by seeing this graph, you can make. Okay.
So one question I had was, see, when we later on do standardization of data, right, using standard scalar or min-max
Yeah,
scalar, the distribution is important, right? Because if it is a normal distribution, then you would typically do standard scalar. Whereas if it is not a standard distribution, normal distribution, then you might have to go for a min-max scalar kind of a model, right?
yeah.
So are we supposed to, I mean, like which distribution, so depending on what I observe here, how do I choose what scaling do I use?
See, this is again a very big question. I mean, there are, as you can see on the discourse also, a lot of discussion happened. I mean, when to use min max scalar and when to use standard scale. Different people can get different opinions on this one. Okay, so but I would say, see, one thing is you understand why you need to scale your data set. That would be my first question. Okay. So one thing, since you said that when it is following the normal distribution, then you will use the standard scale. It is not the case. I mean, it's okay. I mean, if your data set is following some normal distribution, then no need to distribute that. I mean, no need to scale that. Okay, if it is following some distribution, I mean normal distribution at least, not some distribution, normal distribution. Okay, and if it is not following any distribution like these graphs, these are the graphs which is not following any distribution. I mean, at least these are not following the normal distribution.
Right.
Hello. Yeah. So in that case, you need to scale. And why you need scaling is that because see, there are few algorithms like when you scale down your data set, no, or when you scale down your column, or when you scale down your features, no, in that case, it is easy to converge your algorithm. Okay. So that's why scaling is needed, so that your algorithm can converge easily. Okay, and many algorithms doesn't work properly when your data is not scaled, or when your data is skewed, or your data range is very high. Okay, so
right, and also in terms of like linear regression and all that, for example, if it is not scaled, then the coefficient itself will be quite skewed, right?
Exactly.
So items with large values will have smaller coefficients, and probably things like smaller may have, I mean, depending on the data. Then the coefficient will also mislead on the weightage that we are applying to each of these features.
And these are the basic assumption of your linear regression only, that your data is normalized.
Right.
So if it is not normalized, then obviously this linear regression algorithm won't perform properly. Okay.
Right.
So so before so these are the basic assumptions of linear regression only. So linear regression is valid only when these assumptions are true. So I mean your independent variables should be your independent variables should be independent. So you have to avoid multicollinearity. Okay, and other things. I mean, there are different assumptions like homozygosity, normality, these things. Okay, so I think we have discussed in the last time. So that's why I'm saying that scaling is needed. So that was the first question. Okay, so that I answered. And after the second question is that when to use min-max scaler, when to use standard scaler. In general, I would suggest you to use the both and just see like which one is giving you the better results. That is the case, I would say. That is the suggestion I would give. Okay. And different people from or maybe some people can suggest you based on their experience. So that will also work. Okay. Otherwise, in general, I would give you the suggestion only. Okay. Just take both ways and see which one is giving you the better result.
Sure. Each topic, even just scaling itself, seems to be a huge topic. So I don't know where to start anyway. That's I think as you're saying, you'll have to try somewhere.
So in general, I would say that list use standard scaler and just check your answers or check your values, and then otherwise you can also use min-max scaler that you can use, and just see like how many if you see any improvement in your answers or anything or not. Okay, so that's what I would suggest you. For the end. Okay, so that's what I would say. So let's now move to this one. Okay, distribution of independent variable. Okay, let's plot this graph at least, because since it's a dependent variable and we have to focus on this part only. So that's why I have plotted this again. Okay, so that at least a bigger graph to get more insights of this graph. Okay, so we have plotted price here. Okay, see as we know that our data set should be normal. Okay, it should follow normal distribution. So obviously we will scale it. Okay, there can be different scaling, as we said that we can use the standard scaler or min-max scaler. Okay, but if you here we have used np.lockedin. Okay, so just to why we use that is just to normalize your data. Okay, nothing special about it. You can use other things also. I mean standard scaler or anything, standard scaler or min-max scaler also. Okay. So we have so the point is that you have to scale your, by seeing this graph you can see, directly say that your graph is skewed, so you have to scale it. Okay, and from this graph you can see that you can suggest your manager. I mean there are most of the cars are below 10,000 only. Most of the cars price is below 10,000 only. So you can suggest and there are very few cars between 20,000 to 30,000. So your company can make some strategy. Either if your company wants to launch some car in this US market, they should focus on this. Either if they are focusing on the lower end car, so they have to focus on the price of. They should target to set a price around 10,000. And if your company is focusing to make some car on high end, then the price should be around 35,000. I think, yeah. Or any other insights or any other things, if you guys are able to get from this picture, then just say. Or you can also think, or you can also interpret this figure in this way that, yeah, you should, since there are a lot of competitions on this price, obviously, so your company can make the car price little lower than this one. Or and if you are seeing the higher price, I mean higher segment, if you are targeting the higher segment, no, then your car's price should be a little higher than this or anything. I mean, okay. So ultimately, yeah, the strategy you have to make. So these are the graphs which will give you the understanding of market. Okay.
So I have one question.
Yeah, please ask.
Like, what would standard scaler help in this? Like, how would it help with
Yeah,
this?
sorry.
Like, we have a right skewed graph here. So how will a standard scaler help with this?
So what standard scaler does know? It directly just convert. I mean, any samples if you give, it directly converts it to scale it down to like to set mean 0, and yeah, standard deviation as a -1 or 1. Okay, something like that. So like that, it scales a whole data set. Okay, I mean just to set the maximum value to the 1 and minimum value to the 0, and just set mean as 0. Okay. I'm not sorry. The mean value, minimum value is not 0, but yeah, it scales like that only. It just says the mean value as 0. Okay, so it will be a different another topic to like what is the formula of a standard scalar, and yeah, how does it work? Okay, hello.
Yes, sir.
Yeah, so it will be. I mean, you can take the formula of a standard scalar like zx minus mu by sigma. Okay, so
But
based on the,
what would having the values between -1 to 1 do? Uh,
yeah, please. Sorry.
what will scaling down do? Like, how will it help us? Like, if we have maximum value till 1, then how will it help us? Like, why can't we have 50,000 like as
Yeah,
max value?
so that is what I said. So see, if you there are different algorithms which will, I mean there would be a highly affected if your data, if your column value, see, I will give you a normal example. Okay, just see, uh, let's see. Okay, this is a peak RPM and this is a compression ratio. Okay, if you see, this compression ratio affects your, I mean the car performance, the price of your car. Let's say this is a very critical point. I mean compression ratio, your car price is highly correlated with this compression ratio. Okay, if just assume, okay, if you don't have any data knowledge or anything, just assume this one is that, or let's say income. Okay, so this 9 value means that it is highly affecting your car price. Okay, if it is 9, it is 13,495, and if it is 10, that it is 13,950. Okay, but just change in, I mean it changed to 1, 9 plus 1, so the difference is only 1, but here the difference is 500, but after that, I mean the price is changing around 500 rupees. So what I want to convey here is that just by small change in compression ratio, your price is varying a lot. But to change, I mean to but change in, I think around 500 points of change in peak RPM is changing your price this much. Okay, so if you see, I mean your when you will run your model on this one, no, so it will give you the very high coefficient value to this peak RPM. Okay, but very few, I would say, the yeah, the coefficient of this compression would be small. So if you change 1 to this one, no, I mean if let me use the same. So I think if some other person can give want to give it a try, they can give, or otherwise, yeah, I'll explain it using the points. I'll just Okay. So is it visible? Hello?
Yes, sir. Yes, sir. It's
Yeah.
visible.
So let's say your price is something. Okay. This is your price, and this is your, you know that, yeah, it is both compression ratio and peak CTMPG, let's say, or sorry, peak RPM, both has very high correlation with price. Okay. Let's say both have equal yeah, equal correlation with price. Okay. So let's say our formula is saying that 0.5 into price is nothing but 0.5 into C into uh, peak RPM. Okay. We will represent it with P. Okay. So we are getting some formula something like this. Okay. So for the price, for example, here you can see that 5,000 into something, or yeah, we can directly convert it into that too also. That will also. 2 into P card. Okay, something like this we are getting formula. Okay, so if you see here, so for the first case, if you change a small change in the peak RPM, so it will give you the produce the price of the car is 10,000 into something 5.5 into 9, something like this. Okay, but if there is a high change in the your, if you see here, if your algorithm, if your model is something like this, so if you see that there is if there is high change, even if after the high change of uh, compression ratio, no, your model is getting very slightly affected. I mean, do you, are you getting my point, or I should explain it a little more? So what I want to convey is, let's say your price is peak RPM is given, your peak RPM is 5,000. Okay, and your compression ratio is 9. Okay, so 5.5 into 9 plus 25, 10,000, 10,000, okay, 10,000, 4.5, 10,000, 4.5. Okay, so let's say 10,005. Your price is this one only, but when you change it to the 500 points, okay, or it changed from to the, I mean, just change by you change it by the 2 points only. So then if you change it to just change it C value by 2 or anything else, so in that case your model, your price is not changing that much. I mean, your, if your C changes from 9 to 10, if it changes from 9 to 10, no, then your final price changes from 10,004.5 to 10,005 only. I mean, there are very small amount of change. Okay, by def or to summarize this, I can say is that the if you don't scale your data set, no, then it will give you the high weightage to the columns which has very high values. Okay, so the column, so you are seeing, no, your price is highly dependent on this peak RPM. Why? Because this value is very high. Hello.
So
Yeah. So that's why, I mean, when you don't scale your data set, no, it will be highly dependent on those variables which has very high values, and it will there would be not there will be very small amount of change if you change the other if you change those variables which has very less values. Okay, so for example, here if your price is let's say you are giving equal weightage to all the columns. Okay, so 0.1 into this one, 0.1 into compression ratio plus 0.1 into peak RPM also, no, and 0.1 with 2 weightage to all the other columns. Okay, something like that. Then if you're giving your price is, let's say, 5,000, no, if you are changing for the other model, if it is changing from 9 to 10, okay, just say, so how much your price will change? This is the 5,000 value you got when it was 9. Your compression ratio was 9. Okay, but when it changed to 9 to 10, no, the price value will change. I mean, very small. It will change by a small fraction. That is what I want to convey here. Is that if you're if you don't scale your data set, no, then in that case it will give very high weightage to the those columns which has very high values. Okay, in numbers, even though it won't affect your model that much, but I mean, there is Yeah, I would say is that there is not that much. Ideally, it should change a lot if your compression should change from 9 to 10 or something like that. But here you are saying that it is varying. It is not giving you the significant amount of change if you change the compression ratio. Uh, I should use some other examples, I would say. Actually, I am also not able to recollect a correct example which I should use here. But by theory, I would say is that if you don't scale your data set, then it will give the high weightage to those columns which has high range. Okay. So that is the case here. If you don't scale, if you don't scale your data set, it will give high weightage to columns having large values.
So, sir, we should like scale every column which has more than 1,000 value, like which has.
We should scale all the columns. Okay, we should always scale all the columns. That is what I am suggesting, so that all the columns are in the same range. Okay. So here you see your compression ratio is ranging from, let's say, from 8 to 15, but your peak RPM is ranging from 500 to 5,000. Okay. So you have to scale both columns to the same range. Okay. It should be something like -1 to 1 only, or this should be the case for all the columns. Okay. Then in that case, two benefits is there. First benefit, I said, as I said, that it will give, otherwise it will give you the high weightage to those columns which has large values. Okay. And second case is that there are algorithms which performs very poorly on the scaled unscaled data set. Okay. If your data set, if your value range is very high, no, then it will take very a long time to converge. Okay. So for that also you need to scale your data set. And third thing is that it is the basic assumption of the linear regression. Is that is yeah, it is the basic assumption of linear regression, which means that yeah, these if you those assumptions are not true, then yeah, linear regression won't work properly. And I told you the reason why it won't work properly, because it will give you the high weightage to those columns which has large values. Okay.
Got it, sir.
Yeah.
Thank you so much.
Okay. Yeah. So yeah. Okay, we had little less amount of time. So okay. So that's why you have to scale your data set. Okay. Once you scaled here, so we have to remove the multicollinearity. Okay. How we can remove that? We can directly, first thing is that directly plot a heat map. Okay. Here you can see that in this code, dataset.correlation will give you the hit, yeah, to all the correlation matrix. It will print, if you see here, it will give you the correlation matrix. Okay. It's difficult to interpret this one. Okay. Because see how much large it is. So obviously it is a good to plot a heat map using SNS library. Okay. So here, if you won't use absolute, no, the range will be from -1 to 1. Okay. If you use absolute value, then yeah, it will convert all the minus values to, it will change the range from -1 to 1 to 0 to 1. So that's why you are not seeing any negative values here. Okay. From this graph, we can interpret a lot of things. So see, I have plotted the price also. So if you see the price, we can directly interpret that the price is highly correlated with highway MPG and also car width. And sorry, it is highly correlated with the engine size. So we know that once the engine size will increase, the power will increase, and if the power, once the power increase, obviously the price will increase. So it completely makes sense. So the car price is highly dependent on, based on this heat map, I can say that yeah, the car width, which is nothing but the car width and car length is nothing but it is denoting the size of the car. So from from this heat map, I can comment that car price depends on highly on the car size, engine size, and its mileage. So why we are saying that? So since you can say that the higher the engine size, higher will be the horsepower. So it is if you see the correlation between horsepower and engine size, no, that will be very high. Just check that. Okay, this is the engine size and this is the horsepower. So it has a 0.81 correlation. It completely makes sense. Okay. So yeah, from this one you can say that, but it's not a case. I mean, this is just to understand, but you have to drop those variables, which is highly collinear. Yeah, highly collinear. Yeah, which is high correlation values. Okay. So if you see the basic assumption of the linear regression is that your features should be highly independent. Okay. So your features should be independent. That is a basic assumption of linear regression. So before using the linear regression, you have to remove the multicollinearity. Okay. So you know that, yeah. So to do that, you have to perform some featuring. For example, car length into car width will give you the curve weight. Okay. Because curve weight is nothing but the weight of your car when it is empty. Okay. So you know that the car length, car width is nothing but it is denoting the length into breadth. And once we multiply length, breadth into height, it will be the volume of your car. Okay. And you know that the volume of the car and weight of car will be highly correlated. Is it something, or maybe, or otherwise also you can do is that you can merge these three things, car length, width and height, and make a new feature named car volume, something like that. That you can do here. And there can be also like, you just try to remove the features. Okay. So that would be your goal here. Or just, yeah, you can do that by two ways. One is that you can combine a few features, or you can create some new features also. Okay. I think everyone slept or what? Hello? Are you guys with me or?
Yes, sir. We're just trying to look at your code also.
Okay. Yeah, since it's been a long time. Yeah, no one interacted, so that's why.
Can you just slightly scroll up and also just show me the code a little bit?
Yeah, this one.
Yeah.
Yeah, it's just you just use the dataset correlation and no need to use this one. I mean, if you don't want color and all, it's the simple version would be something like this.
Okay, sir. Got it.
Yeah. Simple version of this code will be something like this. SNS. So yeah, this would be the simple version. But as we see that we have to use the annotation, then only we can seek the values. So the first thing would be is that it said the not equal to true. Then we can see that it's too messy. So just increase the size of the graph.
Why have we used absolute correlation?
So just to avoid the negative sign. Okay. Basically, we want to see that which is highly correlated. See, if the correlation is minus 0.53 or plus 0.53, what we want to interpret here is that whether this absolute number is very high or not. Okay. So that's why we have neglected here my negative values. Okay. If you want to print that, that's not an issue. You can print that. Okay. See here, if you see here the negative values, okay, minus 0.50 and minus 4. So it simply means that symboling is negatively correlated with car length. So if car length is high, okay, the car is safe, something like that we can comment from here, because it has negative correlation. And we know that, yeah, if it is when the car length is increasing, the from here I can comment something like this in simple words. If car length increases, the symboling will decrease, and if symboling decreases, we know that the car is moving towards the safer side. Okay, so that's why I made that comment. And yeah, we can just see any other values. Okay, car width and mileage. Okay, so here also we can commit that mileage increases. Okay, so or yeah, just see the simple one. Okay, the price and mileage. Okay, so once price increases, mileage will decrease. So that is what it is making the sense here. Okay, and it completely makes sense. Okay, uh, the mileage of the higher price car is very low. Why? Because because mileage is proportional to the car. I would say that because for the higher end car, people want the engine power. People want power, not mileage. People focus on the power. Okay, so if you see the cars like Ferrari and also, they have very high power, high horsepower, and their engine size is high, but their mileage is very low. Okay, for those people who doesn't have any car the understanding of car and all, so it is that mileage is something like it is showing that per liter how much kilometer your car can travel. Okay, it is something like something a kilometer per hour, a kilometer per liter mileage unit is that. Okay, if it is 54, so it means that 54 kilometer it can travel with 1 liter of petrol, something like that. Am I correct? I mean, whoever has mechanical engineering background, they can say. Hello?
Yeah. Kilometer per liter,
Yeah. That's why. I mean, so that's why when for higher end car, I mean, high price cars, we don't focus on the mileage. I mean, those people don't focus on the mileage. Okay, that you can see on the bikes also. I mean, the lower end bikes has high mileage, but higher end bike doesn't have that much mileage. So that's why this is the relation. Okay. And by changing this color CMAP, you can change the color of this code. So that is what here: hot, cool, warm, jet, where it is. Okay. So we have used the cool warm here. So that's why this type of shape is there. And if you don't use the by default, it is. I also need to check that. By default, it would be a hot. I think I would. Yeah. Any other color? Yeah. Okay, so
what is considered a high correlation? Like what number? I mean, is it based on the domain that we'll have to look at it, or this is just get given an idea? Then there are subsequent methods like select K best and all that, which will basically take care of.
See, ultimately in machine learning, if you see that it's always a iterative process. Okay, so you just use. I mean, no one can say that this is a very high correlation value and that is a very high correlation. See, what we want to do here is that we just trained a model. Okay, just I trained. Let's say I trained a model using the without removing any columns. Okay, the first work would be is that you have to use your data set and you just train a basic model. Okay, base model, I would say. Okay, so once you train that, and after that you just do some iteration in your features or in your algorithm. Okay, or in your code, and after that you just check whether your performance is increasing, your model performance is increasing or not. If it is not increasing, then obviously that whatever you did know, that is not a correct one. Okay, it is like that. So we can't say that whether it's we can't comment that after this particular number this is the high correlation, something like that. Okay, here you can see that highway MPG and city MPG has correlation 0.97. So that I can directly say, this is a very high correlation. Whether I should remove at least one of them, or we can just combine this one and make a combine both values and make a separate feature. Okay. In general, I can make a combined mileage of my car, something like we can give. Yeah. Yeah, hello.
So got it, sir. So the key thing is, see, there are two aspects, right? There is correlation and there is independence. So we'll have to look at both of them separately, right? Because correlation, I mean, high correlation doesn't mean they are dependent. Similarly, vice versa, right? I mean, at least statistically.
Yeah.
Okay, so independence test is something we'll have to do separately for each of these features. Meaning
exactly.
Okay. So what is more relevant? Is it correlation or independence when it comes to training?
It depends on the differences. For the linear regression, it is a basic assumption. I mean, that it is a basic assumption that both the features should have features should not the features should be independent. Okay, so that's why we call it only the target variable as a dependent variable and all other variable as independent variable. Okay, so that's the assumption here. Okay, and in general, see, we avoid we avoid multicollinearity. Okay, why we do that? Why we do that? Because if it is highly collinear, the both. I mean, we will. If you see the code, no, again the same thing I would say. See,
yeah, I mean, multicollinearity I understand because obviously if it is collinear, then you're wasting time in processing all that extra data.
And unnecessarily, it will give the high weightage to those columns. Okay.
Correct.
If for example, if our code is something, let's say 0.1 into something or 0.1, weightage to all the columns. So ultimately, the mileage is getting weightage as a 0.2 because 0.1 plus 0.1. Are you getting my point? So that's why. So
yes, sir. Got it.
Should avoid that.
Sir, hello.
Yeah, please ask.
Sir, does it make any sense to get correlation between car ID and price?
No. Car ID is completely unique value. So it's just an index, so it doesn't make any sense. Okay, it's just that to avoid. Yeah.
So we can avoid it, right?
Yeah, completely avoid it.
And one more question, sir. If we find the correlation, it is giving the correlation between numerical values only. But as we know that fuel type diesel engine cars are price of fuel or diesel engine are on higher side. So fuel type is not interpreted here. So what about those features?
So one thing you can do is that before using this, you can use the one-hot encoding and just check whether it is giving you some insights or not. I am also not sure, but yeah, that is what I would say here. Just use the one-hot encoding, and after that you just check. Okay. Otherwise, you don't have. I mean, this method won't work for that. Okay.
Okay, it works only for numerical features.
Yeah. So that's why, I mean, see, in machine learning, everything you have to convert into the numerical numbers. I mean, because either you have to convert into the numericals or into the vectors. So that's when once you convert into the numbers, then only ML algorithm will work. In NLP also, like first and foremost step is that you have to convert all the text into the numbers, into the vectors. Okay. Then after the process starts. So that's the case here. So there you also you have to just convert into the you can use pd.getDummies or one-hot encoder, and after that. So here in this case we use the VIF factor, okay, just to remove the multicollinearity. Okay. So what we did here is that since we talked yesterday, so that's why we just used it. So in general, variance inflation factor more than 5, if we see a VIF value more than 5, no, then it is assumed that in general it is assumed that it is highly correlated. So again, it's the from where this 5 number came, it comes directly from the experience, or like people who has experience, this is like that. Sometimes they take 5, or sometimes they take 10 also. Okay. So that's the case here. So what we did here is that we wrote a code which will create a data frame, and in this data frame it will print variable and its corresponding VIF. Okay. So to get the VIF, we have simple code like variance inflation factor that and x dot values. Okay. So it will give you the VIF. Okay. Once you okay, since we have just 10 minutes, so I'll just try to wrap up. Okay. Since when I will give you this code, and you can directly check the codes. Okay. And if you get any doubt, you can post it on the discourse. Okay. I'll just try to wrap it up. So what we did here is that at least the basic thing I will teach you. Okay. So you see here, what we did here is that we just printed the VIF. Okay. So what we created a data frame which will print the variable name and its corresponding VIF values. Okay. So once it gets printed, we'll check. What we will do here is that we will remove that value whose VIF is very high. I mean the highest VIF value. Okay. We will remove that column. Okay. So what we see is that here the highest VIF value is for car length. I think car width 2828. Yeah, so 2828 is the highest VIF value. So again we have to write a code. I mean again we have to print the this table by removing this car width column. Okay, so to do that, we have just to use this one only. I mean, this code is nothing but make VIF df data set, and here we have removed this for the first instance. We have removed, see, car ID, as you said that it doesn't make sense to check the correlation between for this one. Then price we have removed because it's a target variable, and then car length. I mean, yeah, in the first step I would say that car width. Okay, just think it like this one. I mean, these things on the first go I haven't used this one. Okay, it is something like this. Okay. Actually it's an iterative process. So for the first one, what we did here is that we will again print this data, this VIF column. I will this data frame, and what we see here is that we just remove the car width. Okay, so we wrote car width here, and after that we got this one, this table, and from this table we will see that which has the highest VIF value, wheelbase. Now again we will add wheelbase in this one. Okay, we'll again add wheelbase in here, and so what we did here is that we removed this wheelbase. Okay, and after that we printed our VIF values. Okay, again we will select one values. Okay, again we are seeing that the maximum value is maximum VIF value is for car length, so let's remove the car length also. So never do it. So one suggestion here is that never see like all the values which is more than 5, just remove that in a one go only. It never do that, because see, just after removing these three things, the VIF value of car length is around 1250, because after each once you remove any values, no, I mean any columns, then VIF value changes for each value, for each columns. Okay, and there can be a case where some column whose VIF value is very high, that can come below 5 after removal of any particular column. Okay, see here. So like this, you will just remove all the VIF, all those columns which has higher VIF, and you at the end you will take only those columns which has VIF values less than 5 or 10. So here we have for this session, or yeah, for this algorithm, we have taken VIF value as 5 only. Okay, or
Sir?
10. Yeah.
So on here, see, the thing is all the values are very big, right? So we need to standardize and then only we have to apply VIF, right? Or
Yeah, exactly. Yeah, we can do that also. Okay. So since we haven't done, yeah, I mean, just I'm telling you the process. So that's it. Okay, we can do that. Okay. So after you, so and the two other thing is that we have very few number of samples also. Okay. So that's why also you are seeing this much high value of VIF. Okay. So yeah, after removal of all the VIF, all the columns which has very high VIF values, we got this one only. I mean, these two tables only. So engine size and in compression ratio. So these are the only these numerical features we have for our model. Okay. So
just a quick question.
Yeah,
quick question. So instead of doing this kind of an iterative process of removing columns, will the sklearn's select k best or something actually work on this VIF and remove it for us iteratively, or is this the only way?
Yeah, you can do. I mean, you can use any ways. You can write any loop, or you can run a loop also. That's a good way. I mean, just now, yeah.
No. So running a loop is fine. What I'm trying to understand is sklearn also has some thing, right? Feature selection.
Yeah. So, but for the sklearn, in the sklearn, this library is not the, this module is not the variance inflation factor. So it is available in the stats model. Okay. So that's why it is not. Yeah. Otherwise, if it is there, if it would be there in the sklearn, then they would have provided some a good way to not do and no. So that you don't have to do this manual iteration. Okay.
Okay.
So that's why. I mean, here you have to write the codes. Otherwise, sklearn provides for all their codes. They have provided some modules. Okay. So that's why, I mean, from here you can see the VIF. Okay. These are the concepts. I mean, in the production engineering, in the production engineering, these concepts are used by a lot. I mean, they use a lot of and they use these things. I mean, because in the last term only, like one guy was there. So yeah, so he was saying that is the Six Sigma belt. They learned about this one. I mean, VIF. So yeah, that's why I got to know this. Okay. So yeah, I just told you one method to remove multicollinearity. That's nothing. Yeah, that is the same here. By this way, you can use the VIF. So VIF to remove the multicollinearity. Okay. So after that, yeah. So what you have to do here from here is that you have to take these two numerical features and you have to see what are the categorical features you have and just merge it. Okay, and create the SNAD data set, and yeah, you can use this new data set to after you can use this new data set to create a model. Okay, after that you have to just use because I have just yeah, we had done some feature engineering also, so that I think I can't take here. So I mean, yeah, you can say like what are the different car names are there. So if you see is that Romero Gio. So Alfa Romeo. So it is a car name, and second, yeah, third string belong. So that so I think it is a model number. I mean, a model name, I would say. Audi 100 and Audi, yes, so these two are same only. So Audi Fox and Audi, so the car company name is same only. Okay, so here is the question was, check how many unique car brands are working in the USA. So by this we can't print this one. Okay, so to do that, yeah, we have to clean this one. I mean to change this string name. Okay, and after that we got to know is that how many Toyota brand of car is there, how many Nissan names, all this thing. Okay, and after that when you print its mean price, no, then we got to know is that Jaguar is the highest mean price. Okay, it is around 5,000. Yeah, it is around 35,000. Okay, so yeah, that is what we 34,600 precisely. And after that you can iterate through each columns, like how many number of, like by plotting a bar plot you can see, I mean, how many front way you can see that most of the car has front engine. Okay, there are very few cars, I mean only 3 cars has engine location at the rear part of the car. Okay, and also you can take the, I mean, yeah, you can get some insights by doing these things. Okay, and after that, yeah, you can directly use no need to use these things. Okay, I mean this is a manual process, you can directly use this that one hot encoder. Okay, to encode all the categorical columns, and once you are ready with these things, no, you can, okay, here I was trying, yeah. So yeah, we were trying to just merge these two features, I mean column city mileage and highway mileage. Okay, so you can do that. Otherwise, okay, let's move to this part. Okay, so model implementation, I mean you can do a lot of things. So the basic sense is that you can do a lot of features, whatever you want to do you can do that. Okay, basic process would is that you have to do the data inspection, and after that you can do some EDA to understand your data set. You can understand your data set in a better way, and after that you just train your model and just try to improve the performance. Okay, I think do you got my point or anything? Hello?
No, yes, sir. Got it.
Yeah. Since in this session, I mean these things, I mean even 2 session is not enough for this collab. Okay, like since it is long enough, so yeah, that's why I'm saying that 2 session is also not enough. Okay, every time we just I mean always we struggle with the time constraint in this
So
collab.
categorical features after encoding, we should do this like that VIF thing, or it's like why did we not doing this VIF for categorical?
Uh, you can, because otherwise it will be too long, because if you use the category of feature, if you use the encoding, no, see, you have around, after the encoding you have how many number of columns you have, 43 columns. Okay, you can do that. I mean I also don't know like what would be the like result. Seriously, I don't know, because usually we do we do for the numerical columns only. So you can try that and just see whether you are able to improve your performance or not. But it's not a general practice. I mean usually, because after one out encoding your column value will increase a lot. I mean there would be very high number of columns, and the main idea behind this by using VIF is that you want to remove multicollinearity. Okay, And there can be, I would say, I can't make a general comment here because there can be a multicollinearity between the categorical columns also. Yeah, I can't make a general comment. So I would suggest you just check. But in general, what we do is that we check it for the numerical columns only. Okay.
Okay, sir.
Yeah. So after that,
So just-
please ask.
Sorry, so just a quick before. I mean, is it possible when you after you share this collab, we go through it because it seems to be a fairly detailed collab.
Yeah.
Is it possible to have another session, not this week, sometime early next week, where we can go through the collab again, ask our doubts and so on? Because it seems to be a good collab. I mean, it's a detailed collab, so.
Yeah. Okay. We can make a session. Okay.
Because otherwise, asking questions on discourse, I mean, it helps, but sometimes interactively, just you might solve the question then and there.
Yeah.
I think we can have a session on Monday because we have no classes.
On Monday, I think Monday there would be a Durga Puja, and most of the people are on leave now. I mean, in the next week, next first 3-4 days. So that's the case. So I doubt about that. But yeah, no. I mean, yeah, we can make a session on this one. I mean, if you want any questions on this collab, no, yeah.
Sure, because this is dealing with some real data also, so I think it will help
Yeah.
us kind of understand
Yeah,
it. Come back to you with questions. Maybe you can walk through it or something like that.
Yeah, ideally, I should also do that. I should because we don't use that method, but otherwise, I should share this collab and at least this data set earlier only, so that in the session we should discuss only the model implementation part and feature engine part. Okay.
Sir, if you're going to be next, what to say, conducting the next session, so in case if you are going to prepare the next collab, so you can share that, sir, so we can spend.
Yeah. So I think next session I would take in the week 7 only because we have week 5. Sadhu sir will take, and after that Dev Jyoti will take. So yeah.
Oh.
And yeah, so it's a week 4 now, so that's why I just try to take to keep all these things in the this session. And I will also suggest. I mean, but if from the next session, I mean, whenever if you see this type of collab, no, I mean where this covering the collab in 2 hours is not possible, then we will definitely share that. Okay, that is so that you can go with the ADA part and all. Or anyways, I mean, okay, I'll just talk with others also, and we will try to share the dataset link, at least dataset link with you before the session only. Okay. So that in the session you come prepared way for the So at least you should have some grip on the dataset. I mean, what is there in the dataset, so that we can reduce the time. Because in this session also, like I think 30 to 45 minutes we spent on the initial part only, like the dataset inspection part. Okay, which was needed at least because none of you knows their datasets, so that's and also see model impedance and so on, because from here what we is there that you have to just split your dataset and you have to perform like first you can perform linear regression, then you can perform lasso, raise, elastic net, just check the model performance. Okay, from here I think maybe in the last session we have you have written some code and we would have done some iteration, so that's why some errors are there. So I think you can print the mean, square error, and RMSE values. Okay, R2 score, adjusted R2 score, for everything you can print. Okay, and you can just change the model also. I mean, you can use lasso, raise and all, and check. I mean, which there are multiple things you can change and iterate. I mean, you can change what is the score. I mean, which score is working better for you, and whether it's MSE, whether it's RMSE, or R2 score, or adjusted R2 score, which one is working best for you. Okay, so that's the case here, and so that's what we did here in this collab. Okay. The last we have written. Many see that is what the question. I think in the last session also someone has asked this one. Okay, so since many machine algorithm performs better or converge faster when features on a relatively smaller scale or close to normally distributed. Okay, so scaling and standardizing can help features arrive in more digestible form for the algorithm. So that is what I written here also, is that so when your I mean, things your algorithm will converge faster if the data is scaled. Okay, so that's why it is needed, and also because otherwise it will even two things will happen. I mean, first it will take a very large time, or it can be also possible that it doesn't converge, it won't converge, and second thing is that it will provide very high weightage to those columns which has high numerical values. Okay, so that's the case here. I think that's more or less that is covered in this session. Okay, so at least what you have to do is that you should use your data set first. I mean, just use your data set, just use the one hot encoding in the next step, and after that one hot encoding, directly train the linear regressor model. Okay, and see what is the R2 score you are getting. That's the base model. Okay, use one hot encoding, and after that split your data set and use R2 score to get the result. Okay, and after that do some iteration. I mean, after that just see whether there is a multiplicity or not. If you have multiplicity, just remove that and see whether your scores are improving or not. You can also use the, and after linear regression you can also change it to the with the lasso regression or ridge regression, whether your score is improving or not. Just see here. I mean, or in the lasso and ridge you can obviously use grid search CV to iterate the alpha values. Okay, and by changing the scoring method also here, you can change the scoring method and see which scoring method is giving you the better result. Okay, so from here just see the what we have done here is okay, just see RMSC. Okay, R2 score will okay, just consider R2 score. Okay, so when we have used the art which one is that? I mean, here they have trained, which we trained the model using. Okay, yeah, it's a simple linear regression model. For simple linear regression model, our model is giving the R2 score value as 0.85. Okay, and once we use the R2 score, our R2 score is somewhere around 0.97. So you see here, I mean, just by changing the estimator from linear regressor to lasso, our score improved a lot, directly 0.85 to 0.97. That's a huge, I mean, yeah, improvement. And in this one, what here we have set some alpha values. We have directly set the alpha value as 0.001. So what we did here is we used a set of alpha values and just see like which alpha value is giving you the best model. And if you see here, R2 score is somewhere around 0.85. So I think it got decreased. Maybe there would be some changes in the code, or I don't know. I mean, because in the last session we had in the last run, the term 2, I had run this collab. So yeah, that's why maybe we would have done some iteration. Okay, so if you see here, and if you have used ridge regression, and in that case our model is giving the R2 score as 0.87. So obviously I don't know. I mean, so yeah, maybe it would be that after some featuring I would be getting this one lasso score. Okay, because I am mixing, because in the last session I haven't covered this part, at least this one, I mean this featuring part. So that's why this score changed. Okay, so without featuring we are getting R2 score somewhere around 0.83 to 85, or yeah, after the elastic native our R2 score is around 0.88, something like that. Okay, you can do all these things. Okay, just try to improve. Here see by elastic net. Okay, by elastic net it is giving it the R2 score is 0.9. So at the suggestion is that first you do the, I mean, okay, let's write here. You have your data set, just do these things, basic inspection, and after that remove. Null and duplicate. You can remove without or remove or replace. You can also replace it with mean or median value. So see Here you don't have this null and duplicate values, so no need to worry about this. After that, split the data. Okay, before splitting, you have to encode the cat columns. Okay, and after that, split the data, and then okay. After these scores, okay. Or after that, this you can lastly you can also is elastic net. You all these things you can use, or SGD degrees, whatever you have learned till week 4. No, you just try to use all those learnings. Okay, this is a data set where you can try all your learnings up to week 4. Okay, elastic net. Once you are done with this thing, no, after that just try to do that. I mean, what I was saying, that just try to do some feature engineering. What does it mean is that just try to, okay, let me write SGD. Okay, so these things you can just oh, yeah. Yeah, these things you have to do here with this data set, and once you are done with these things, no, and after that you can do some, after these 9 steps, then you can do some featuring, like you can remove some value, some columns which has very high multicollinearity or anything. I mean, okay, you just try to do that, and based on that, after that, just check like whether your accuracy is increasing or not. Okay. So yeah, that's what I wanted to convey. Is there anyone having any doubt? Or okay, one marathon session. Okay, yeah, we can plan that. That's a good thing. Hello. Yeah, someone can ask, say anything.
Yes, sir. Yes, sir. In Python, sir, Sudarshan sir used to take some marathon kind of session, long
Okay,
sessions.
okay.
So
So
in the evening, that can help us.
what
In
was what
one
does,
session,
okay. What does that mean? Can you say? I mean, it's a long session, that I understand. So
sir, in the one session, the whole process we can understand. Like in this session, we were restricted to the only data exploration part only.
yeah.
So in one go, we can understand the whole process.
Yeah. Okay, we can plan that also. Okay, something like that.
Yes, sir.
Yeah, so, why I stopped here is that because in the last session, in this term I'm taking few session in Python also as well. So there I saw in the last session, I'm talking about the just last session, which I took in the week 3. Okay, in week 3. So that session went for the 3.5 hours. So they, I mean, there were few people, they complained is that sir, it's I mean, it's difficult to stay that long, and so that's why it would be nice if you split the sessions. So that's why I said there were. So that's why I tried to complete the time around 2 hours only. Otherwise, it
No, sir.
will.
If you communicate us in priorly, then we can mentally
Yeah,
prepare for the session.
yeah,
And in,
that
in between, we can have one break for 5 minutes.
yeah, that can work. Okay, from the next time we will definitely do something on this, because this was the first SWI of this type of because like where you have data set and you can do multiple things. I mean, you can see that you can cover the first 4 weeks. I mean, completely. You can use all the concept of first 4 weeks here in this data set. So that's why, yeah.
Yes, sir. It was very useful session for me.
Yeah, glad to know that.
Sir,
So
where,
yeah,
sir,
yeah,
where
please.
we can get the link of this collab? Is it available in supplementary section?
Yeah, it will be available as a PDF too for you guys. Okay, so just check whether it would have already available. I mean, I assume that. I also don't know. I mean,
No, sir, it is not available.
okay, okay. So otherwise, yeah, we will talk to the UAD team. They will share it with you. Okay.
So you won't be able to share the collab itself on this link, is it, on this chat?
I can share, but ideally the practice is to share the PDF version of SWI.
Okay.
So that
Last time Devjyoti sir had shared, I think.
okay, okay. So I mean, he said, okay, if you want, I can share, but that's not a practice, general practice.
Okay.
Which is,
No, I thought the SWI could be shared. I understand that
yeah,
the lecture collabs can't be shared. I mean, other than
yeah.
PDF.
And and then the previous terms also, like we used to share the
PDF.
PDF version of the SWI also as well.
Okay.
So if you check on the portal, okay, I will check on the portal. Okay.
Sir, last week I raised about that updating the MLP
Yeah. Week
play,
2, no?
no
Or
playlist for MLPs in the YouTube channel, so that in case if you need to revise your.
okay, so you are not able to get that?
Yes, sir. In YouTube, it is not available. Can you have a look at it?
Okay, okay. Just now I will just check. Okay. Okay. Zoom. Okay, so that is not available. So yeah, you guys were correct. It's not available. We used to say this device. Yes. Yeah, it is not said. I will share it. Okay, don't worry. So here we have only solutions. Okay, regarding that. Okay. Yeah. So so have you seen this one? PS2008. Hello.
No, sir.
Yeah. Here for these terms sessions recording, it is available here, okay, on CS2008. Okay.
Okay, sir.
Yeah. So I think, yeah, by default this is the new. I mean, if you use the Gmeet, if you use Gmeet to live stream, no, then it gets saved here.
Okay, CS2008.
CS2008. Okay, by course name, because yeah, if we once we start streaming from Gmeet, no, it gets saved here. But for the, yeah, for earlier term, it was there in the ITM BSc portal. There the playlist was there. But yeah, so that's okay, and you can get the link. Yeah, for each session, YouTube link, it is available here. Okay. Anything else anyone would like to say there, or any, yeah, any idea, any doubt, anything? So how many of you are from North India, and yeah, how many of you are from South India? I mean the Durga Puja, I would say. Okay, okay, I'll stop the live stream as of now. I mean, Yogendra has raised hand. Okay, so you are from North India, yeah?